Hello everyone, you're welcome to the channel. So in today's video we're treating permutation. Okay, this is from your JAMB syllabus. So the first thing you need to know about permutation is that permutation has to do with arrangement. Okay, permutation has to do with arrangement. A, B, C. Now if you want to look at the ways of arranging these objects, you need to consider them turn by turn. So let's start with the arrangement that are beginning with A. So we have A, B, C. Then we repeat our A here, then this one will be, bring this back here, that will be A, C, B. Okay, so these are the arrangement that you can have starting with A. Then let's start with B. So you have B, A, C. Then you have B. Let's bring this one back here. So you have B, C, A. Then let's start with C. So arrangement that you can have. If you count them in total, you have 1 to 6. These are 6 arrangements. So there are 6 ways of arranging 3 objects. Okay, there are 6 ways of arranging 3 objects. So you see the number of permutation or number of ways of arranging 3 objects, picking 3 at a time, is 6. Okay, now permutation has a very simple formula. So this is the formula of permutation. Now in symbolic form, permutation is written as NPR. NPR. N is the number of objects available, R is the number of objects needed. So if you have 5P2, it means that you have 5 objects. You're trying to arrange them 2 2. You're trying to pair them 2 2. So you have 5 objects and you are picking 2 2. Okay, so that's why it's called 5P2. Then if you have 10P3, that means you have 10 objects available and you're trying to arrange them in threes. That's in, you're picking them 3 3 3 3 like that. Okay, that is 10P3. So to better understand permutation, you need to know what is called the factorial notation. And this is the factorial notation. This is the symbol. This is the symbol of factorial notation. So if you have factorial, just has to do with repeated multiplication in decreasing order. Okay, so if you have 3 factorial will be 3 times 2 times 1. So you start from 3 and multiply in decreasing order until you get to 1. 5 factorial will be 5 times 4 times 1. So you start from 5 and multiply in decreasing order downwards. Let's take the last one. 7 factorial, for example, will be 7 times 6. So factorial just has to do with repeated multiplication in decreasing order. Okay, you need to understand this before you can actually understand permutation. So now let's move to the permutation formula. So this is the permutation formula. So you have NPR is equals to n factorial over n minus r factorial. Don't forget, n is the number of objects available, while r is the number of objects you are trying to pick or trying to arrange. So if you have something like 5P3, that means you have 5 objects and you're trying to pick 3 at a time. So n is 5 and r is 3. So this 5 here stands for n and this 3 stands for r. So 5P3, if you try to evaluate it from this formula, you're going to get 5 factorial divided by, then n is 5, don't forget. So 5 minus 3, that will give you 2 factorial. Then you can now evaluate this further if you want to. Then 6P2, for example. So n is 6 here, y r is 2. So you have 6 factorial divided by, then 6 minus 2, that will give you 4 factorial. Okay, so this is how to use the factorial notation in terms of permutation. The permutation formula is given by what you have here. NPR is equals to n factorial over n minus r factorial. So you have n objects or n number of objects and you're trying to arrange 3 at a time, or you're trying to arrange 5 at a time. So r is the number of objects you're trying to pick, you're trying to arrange at a time. Okay, so don't forget this formula, very important. So welcome back. I'm going to teach you guys how to evaluate factorials in your permutation. So the first one here, we have 5P2. So 5P2. So 5 is n. So you have n number of objects. You have 5 objects and you're trying to pick 2 at a time. So n is 5 and r is 2. So put it into this formula. You have 5 factorial divided by then 5 minus 2. That will give you 3 factorial. So 5 factorial is 5 times 4. You're dividing it by 3 factorial, which is 3 times 2 times 1. So you can see that these parts are the same. These parts are the same. This part will cancel out. So you have 5 times 4, which will give you 20. So that means there are 20 ways of arranging 5 objects, picking 2 at a time. So you have 20 ways, or just say 20. The next one is 7P3. So in this case, 7 is n, r is 3. So into this formula, you have 7 factorial divided by 7 minus 3. That will give you 4 factorial. 7 factorial is 7 times 1. Then you divide this by 4 times 1. 4 factorial is 4 times 3 times 2 times 1. Notice something, these parts are the same, these parts are the same. So they cancel out. So the next part is 7 times 6 times 5. So that will give you 210. For the last one, you have 6p4. So n is 6, and r is 4. So we're using this formula here. Okay, so we have 6 factorial divided by 6 minus 4. That will give you 2 factorial. You break down 6 factorial, that will give you 6 times 5 2 times 1. Divide this by 2 factorial, which is 2 times 1. So you see that these parts are the same. Then the next part, you're going to have 6 times 5 times 4 times 3. That will give you, okay. So this is permutation in a row, which is the next part in your syllabus. So in how many ways can the following be arranged in a row? So you have the letters of the word John, John. Then you have 1 2 3 4 5. If you notice something, there's no repetition here. You just have J occurring once, O occurring once, and so on. Then here you just have 1 occurring once, 2 occurring once. So no repetition in this case. So if you want to arrange these elements, these objects in a row, all you have to do is know how many elements are there first. So here you have 4 elements. So here n is equals to 4. So the way to arrange them in a row will just be 4 factorial. 4 factorial. 4 factorial will give you 24. That is 4 times 3 times 2 times 1, which is 24. This next one, you have 5 objects in a row. None of them is repeating. So you have 1 2 3 4 5. So the way to arrange them is 5 factorial. 5 because there are 5 elements here. 5 factorial will give you 5 times 4 times equals to 120. So this is 120 ways of arranging 1 2 3 4 5, picking 5 at a time. Then for the letters of the word John, it is 24 ways, picking 4 at a time. Okay, so that's how to do permutation in a row. Now let's move to cyclic permutation. So when you are dealing with permutation in a circular form, or cyclic permutation, or you're trying to arrange objects in a circular path or along a circular path, the formula to use is n minus 1 factorial. Okay, if you want to arrange 5 boys around a circular table, 5 boys around a circular table, so n will be equals to 5. Then plug into this formula, that will give you n minus 1 factorial, which is 5 minus 1, that will give you 4 factorial. 4 factorial will give you 24. Okay, now that's how to arrange objects in a cyclic path or around a circular path. But there's another formula that you can also use. If this is a wire, for example, maybe a circular path that can also be turned around, as in that can also be turned around like a chain or a bead, the formula is different. The formula I'm going to use is n minus 1 factorial divided by 2. Okay, this is the formula for use if it's something like a wire or something that can be turned on itself. Okay, then you're going to use this formula. But if it's just a rigid arrangement, like arrangement around a circular table, this is the formula to use. But arrangement along a wire or a bead or a chain, something that can be turned on itself, is the formula is n minus 1 factorial. Let's assume you want to arrange 5 beads on a circular path or in a circular wire. The formula to use is n minus 1 factorial, then divided by 2. So n minus 1 factorial will give you 4 factorial divided by 2, which will give you 12 as the answer, because 4 factorial is 24. So 24 divided by 2 will give you 12. So this is about cyclic permutation. Very, very simple. If it's a circular arrangement that is rigid, that cannot be turned around on itself, the formula is n minus 1 factorial. But if it's like a wire or a bead, then the formula is n minus 1 factorial divided by 2. So when you're dealing with permutation with repetition, as in permutation in which there are some elements that are repeated, the formula to use is what you have on your screen right now. N factorial divided by a factorial, b factorial, c factorial. This a factorial, b factorial, c factorial are the repetitions that you have in that particular word. Take for example a word like Nigeria. Nigeria has some repetitions. You can see that I is appearing twice. Okay, so I is appearing twice. You have to take note of that. The way to permutate an object like this is very, very different from the way you permutate another object that does not involve repetition. So if a permutation involves repetition, the formula to use is n factorial divided by a factorial, b factorial, c factorial, where a, b, c are the repetitions that you have in that particular word. Now let me give you an example. So now it might be asked in your examination, a question like this: in how many ways can letters of the word intelligent be arranged? Intelligent. The first thing to do is to count the number of letters in the word. So you have 1, 2, 3, 4, 11. So n is 11. Okay, n is 11. The number of objects here. Now let's count the repetitions because there's some objects repeating here. So I is occurring twice. Then let's count the next one. T is occurring twice. So T is occurring twice. Then we also have E. E is occurring twice. Then we have L. L is occurring twice. Then you have N. N is occurring twice. So these are the number of repetitions that you have. So the permutation for this particular word, intelligent, will be equals to, look at the formula you're going to use here. N factorial is the number of letters in the word. So the number of letters in this word is 11. So you have 11 factorial divided by, then these are the repetitions. So you just put factorials at the back. So you have 2 factorial for I, 2 factorial for T, 2 factorial for E, 2 factorial for L, and 2 factorial for N. Okay, then you go further and evaluate this. Okay, so it's very, very simple. First of all, count the number of letters in the word, then look for the repetitions. Let's have another example. So our next example here is the number of ways of arranging the word mathematics. In how many ways can letters of the word mathematics be arranged? The first thing to do is to count the number of letters in the word. So let's count. So you have 1, 2, 3, 4, 5, 6, 11. So you have n equals to 11. The next thing is to count the repetitions that you have. So you have A occurring twice. You can see A here occurring twice. So A is occurring twice. Then let's count what else. Then you have T here, T here, T is occurring twice. Then let's check again this. So M is occurring twice too. M is occurring twice. These are the repetitions. Then let's use the formula right here. So we put it into that formula. N is 11. N is 11. Don't forget 11. 11 factorial divided by, then the repetitions are 2, 2, 2. So that will be 2 factorial, 2 factorial, 2 factorial. Then you go further and evaluate this. At times you might see it exactly like this in your option. Okay, so that's how to do permutation with repetition. Now move to the next one, which is permutation without repetition. I'm going to explain permutation without repetition using this simple question here. In how many ways can the letters of the word fruits be arranged, picking 3 at a time, if no repetition is allowed? So in this case, repetition is not allowed. That means whatever you have used or whatever you have picked initially, you cannot pick it a second time. So the way to solve this question is very simple. You just draw, you are picking 3 at a time. So you just draw 3 boxes like this. And you have the letters fruits. So there are 5 in number, n is equals to 5. If you count it 1, 1, 1, 2, 3, 4, 5. Okay, so n is 5. Now you want to fill these boxes with the choices from here. So it's very simple. So this first box, you need 3 at a time. So this first box that is here can be filled up by any of these 5 letters. F can go into here, R can go into here, U can go into here, I can go into here, and T can go into here. So any of the 5 of them can be inside here. So there are 5 ways of putting letters into this box. So I've already used 1 letter. So if you have used 1 letter, that means you cannot use letter again. So let's just assume that you have used letter T. So you cannot use letter T again. So right now there are actually 4 letters remaining, F, R, U, I. So any of these 4 letters can go into this box. So there are 4 letters that can enter into this part. So let us assume I've already used I now. So that means there will be 3 letters left, F, R, U. So any of these 3 letters can go into this box, and this part will be 3. Then you multiply your choices. So you have 5 times 4 times 3. So 5 times 4 is 20. 20 times 3 will give you 60. So there are 60 ways of arranging these letters of the word fruits if no repetition is allowed. Okay. So welcome back. I made a slight change to the question. Okay. In how many ways can letters of the word fruits be arranged? Okay, 3 at a time if repetition is allowed. So I added this word repetition. So repetition is allowed in this case. You are picking 3 at a time. So that's why you have 3 boxes. But this time, anything you pick, you can also pick it a second time. Okay, you can pick it again. Okay, so there's no deduction in this case. Everything will remain constant. So this first box 1 can be filled up by any of these 5 letters, F, R, U, I, T. So any of these 5 letters can go into this box. So you can write 5 here times. Now I've already put a letter here. Now I'm using repetition. I can also put that letter back again. So I'm having fruit constant. I'm not deducting any letter because there's repetition. What I've picked before, I can also pick it a second time. So you also have 5 letters. Then this second box can go for these 5 letters. So this part will be 5. Now there's no deduction. It's still fruit because it is with repetition. Then this last box can go with any of the letters fruits. Any of the 5 can go into here. So you have 5 times 5 times 5, which will give you 125 as your answer. So there are 125 ways of arranging letters of the word fruits, picking 3 at a time with repetition. So